Here we have an array which we are going to convert it into heap, and once this array has been converted into heap, we are then going to apply heap sort on this array to get a sorted array. So the things that we need here are, first of all, a constructor. Now this constructor takes an array, and since this heap is going to have state, we can then define an array variable which will store this array that we pass as a parameter. Then we also need to know the size of the heap at any given point in time. So the size of the heap and the size of array can be different, so that's why we have another variable called size. Initially the size of the heap and the size of the array will be same because we are not going to extract any element, so the size of the array doesn't shrink or expand as such. And we don't have to actually use this dot size because we don't have a local variable called size, but I'll just use it for completeness. Then after we have initialized the array, we then have to call a function called build heap, which is going to convert this array into heap. So we will call this dot build heap, and then we have to define this function build heap. So this build heap function will be void because it isn't going to return anything. It is going to manipulate the array in place, and because in Java we pass arrays by reference, so it's the same array which we are using in the constructor and in the build heap method. So how does the build heap method works? So the build heap method will iterate over all the elements, all the nodes which are not leaf nodes. And one more thing, the heap nodes start from n by 2 to n. So if the length of the array is n, the leaf nodes are from n by 2 up to n. So then we are going to iterate over the size of the heap divided by 2 minus 1, because that's where you have the first non-leaf node, and while I is greater than or equals to 0, I minus minus. So those are all the nodes that we have to iterate. To every non-leaf node we have to apply this method heapify. So as such, heapify takes the index of these nodes. So now we have to write this method as well. This will take an index which is an integer I, and actually you don't even have to use this because it's the same thing. Like, I come from a Node.js background, JavaScript background, that's why I keep using this everywhere I am writing a method. You don't have to do that in JavaScript, so you can remove it from here and you can remove it from here as well. Why do we have this error? Is undefined. Okay, so we have to give it a return type. So the return type of heapify is void, again because it is going to do everything in place, and this is the most important part of heap sort algorithm. Why? Because this has the entire logic, and this is a function that will be called again and again. You will see even from other places in the code. So what this method does is it will take a root node, so we'll call it root index, and with this root index it will try to find out the left child and the right child. Since the left child and the right child have a difference of 1 between their indexes, I'll just use the left child and I will derive the right child by adding 1 to it. So that's your left child, and now we have to compare all these three elements, the root index, the left and the right child, and we have to find out what's the maximum element in all of these, so that we can then put the maximum element as the root of the heap of the max heap. So we are going to do, first of all, we have to check if this child is a valid index or not. So if the child is less than this dot size, or just the size, so size is the size of the heap, so a child cannot sit outside the heap, or otherwise you can also get an index out of bounds exception if the child if this index child is greater than the length of the array itself, and of course it cannot sit outside the heap. So that's why we are comparing that that this index child is actually less than the heap size. And then again we have to do this for the right child as well, so child plus 1 less than size. Now If this is less than the size, then we have to find out which of these is bigger. So if array of child is greater than is greater than the root index, then we need a max index as well, which by default would be the root index. So if that happens, then our max index is the child, and otherwise it's the same. So otherwise max index will be equal to the root index that we had up top. And what is wrong with it? We have initialized it. So what is it? Value of local variable max index is not used. Okay, we'll see what that is. If child plus 1 is a valid index, and if the value of child plus 1, if that is greater than the root index, or not the root index but the max index. So there's a difference between root and max. We have to find the max value, so we will always compare it with the max index and not the root index. So that's a mistake that I keep on making, but that is something to remember. We always use the max index because we are trying to find out the maximum element. We are not only looking for the root index, we are not only comparing this with the root index, but we are comparing it with the left and the right child as well. So now if the value of the child node, the right child, is greater than the value of whatever was maximum between the root node and the left child, so we will initialize that value to the max index. So that would be child plus 1. First of all, what we are going to do is we are going to swap the max value with the root node. So that is root index and the max index. And what I'm going to do is I'll write a static method. So I'm also passing the reference of this array where we have to swap it. Void swap takes an integer array, takes 2 indexes which have to be swapped. So then this is very simple, equals to array of A equals to array of B, and array of B equals to temp. It's very simple. So we'll swap these 2 elements, and then we have to compare. Then we are actually checking if the root index was changed. So in case the root index was changed, we have to then apply the heapify algorithm to the location which was swapped with the root index. So in case the root index is not equals to the max index, which means that these 2 elements were swapped, the element at the root index and the element at the max index, in which case we have to apply heapify to which one do you think we are going to apply it to? The max index, because that's the element that has been swapped with the root element. Root is already the maximum, so the max index is the one which has been swapped, so because of which the subtree that it forms may not follow the property of max heap. So that's why we apply it here. So this far what it's going to do is, once you call this heap constructor, it is going to build a heap, but we now also want to look at we also want to know what this heap actually looks like. We may want to verify it, so we can create a method which returns the heap. And we'll also need 2 more methods for heap sort. One is one method would be just the size of the heap, so as long as the heap is not empty, we keep on extracting one element. And the other would be I don't know if we need other method, so let's just write this method, int get size. This will return this dot size. Again, you can simply return size. And then you need another method called extract root or extract or something like that. So I'll just call the name of the method extract root. Okay, so that's auto completion. So what this method is going to do is, it is going to take out the maximum element and it will return the maximum element. But anytime you extract the maximum element, you also have to replace it with the last element in the array or the last element of the heap, and then you have to apply heapify to the root node. So the max would simply be the element at index location 0, and then we have to replace this with the last element. So the last element is simply size minus 1. So we'll call it minus minus size, because the size of the heap will also decrease. So instead of calling array of size minus 1 and then size minus minus, you can do it in one line. Once that is done, then you call heapify on index number 0 and you return the max element. So I think that should be it. That should do pretty well. Now we need to print these elements. So while, and of course we need to create an instance of heap. So heap h equals to new heap, pass it in the array. Now we have this heap. So while h dot get size is greater than 0. So while there is an element in the heap, we are going to extract that element and print it out. H dot extract root, and we'll just leave a space there. I think that is all there is to it. Let's run this and you will see that, do we get a sorted array? Yes, we get a sorted array. So yeah, that's all guys. Let me just walk you through again what we did. So we have a main method. From this main method we are creating an instance of the heap. As soon as we create the instance of this heap, we will be calling this build heap method. So what this will do is it will create a heap from this array. How does it create a heap? It takes the last non-leaf node, and from there it backtracks to the root node. So this is the last non-leaf node, and it will come up till the root node, and for every node it is going to call the heapify method. The heapify method, what it does is it finds out the maximum element between any given node and its left and right children, and whichever is the greatest, it replaces that with the root. And if there has been a replacement, so here you will see that if there has been a swapping of values between the root index and either of the left or right side, it is then again going to call heapify on the element which was changed with the root node, on the index which was swapped with the root node, and it does that. So after calling this constructor, the heap constructor, we have a heap. On that heap we are checking for so we are just checking if there is an element. As long as there is an element, we are calling extract root and we are just printing it out. So yeah, that's it. I'll try to post this somewhere in GitHub so that you can take a look, or I always like, it's always better not to look at the code and try to do it yourself, because that way you will find a lot of bugs yourself, and then after that you will be able to understand the algorithm in a much greater detail than you can with a tutorial. Even though I have tried to cover everything, there is always something that you are going to miss. So yeah, be sure to watch the tutorial again if you make a mistake and try to write this algorithm yourself.